Hello, wonderful people. Here we are, still in chapter 32, electrostatics. Today is section 6, charge by induction. Ways to charge. There's the big three, friction, contact, and induction. And tomorrow we'll talk about polarization. That's how you make the balloon stick to the wall. Polarization. Induction. Oh, friction. Just to remind you, we're going to talk about this later. Friction is when you have the plastic rod rubbed on the wool fur, and the electrons come off the fur and stick to the rod. All right, here's induction. I've got a metal ball A and a metal ball B, and they are sitting on top of a column. That column is made of glass, and as you know, glass is a very good insulator. So no charge will travel from A down to the ground in the brown. So A and B, those two metal spheres, are both in contact, and they have electrons in them, but they're mixed in with the protons of the atoms and molecules, so there's no net charge. Now, I'm going to use a separate charge to move the charges on A and B. Oh, right, without contact. And that's the tricky part. The charge that I'm going to bring in never touches A or B. So here we go. Step one, two metal objects are touching each other in contact. Now I'm bringing in a charged object. That's a rod with a bunch of electrons on it. And I get it close, but I don't touch. So those electrons push away the electrons that are in the surface of A and B that are free to move around. And that leaves a positive charge close to the rod. You see the little charges, red or negative, green is positive. Pretty straightforward, right? So there it is. And now, that causes the charges to move. Got ahead of myself. I do that. Oh, and please note, the positive charge is on A and the negative charge is on B. So, step 3. You pull the metal spheres away from each other. So now they're not touching anymore. Then step 4, you remove the charged rod. So now that that's out of the picture, what do you think happens? Step 5. Well, the electrons that are on B just spread out like they're pushing away from each other, so they separate and spread all over the surface. And the same for the positive charges on A. And now we have a bunch of positive charge on A and a bunch of negative charge on B. Now, did that rod ever touch A and B? Nope. So that's kind of the magic of it. And by magic, I mean physics. What's next? Oh, the end. You've now created two charged objects without ever having any physical contact from the charged object that caused this. Well said. Can we talk about vocabulary? The word move. It is possible to pick up charge and then move it to another location. Is that what happened on the metal spheres? Well, I didn't pick it up and then move it myself, right? So to what extent were the charges moved? Yes, the charges did move around on the spheres, but they weren't moved by somebody picking them up and carrying them. The word persuade, to advise or urge a person to do something. So is that what happened? Did we persuade the charges to move around? No, because persuade implies that you're talking, you're making a reasonable argument. That's like how you would persuade another person. You could even persuade a dog by saying good doggy or bad dog, but there's no communication going on to the electrons on the metal sphere, right? Are you with me so far on this? Okay. Because here is the word induce. Induce is a verb, and it means to lead or move by persuasion or influence. Influence. That's an interesting word. You induce by influence. Now, if you induce by persuasion, that means you're talking to them, but you can also induce by influence, which means not talking. So is that what happened on the metal spheres? Were the charges induced to move? Were they persuaded to move because the negative rod came close? Were they influenced by the negative rod that came close? Ah, there we go. Do you see that? The charges were influenced by the negative rod that came too close. And that's why we use the word induce. Now, the word induce is a verb. Induction, oh, I didn't change it there. It's supposed to say induction is a noun. Induce is a verb, induction is a noun. And induction means the act of inducing, bringing about, or causing. So that's why we say charging by induction, because we brought about the charges to move. We didn't touch them. We didn't move them ourselves. We didn't persuade them. We induced them to move. Is that what happened on the metal spheres? Were the charges induced to move? Yeah. So, for the English class people, does this make sense? Do you like this explanation better? Why we use the word induction? I assume that you are okay with that pictures, right? The pictures are straightforward. The metal spheres are in contact. You bring in a charge over there, a bunch of negative, so it pushes away the negatives. And then you separate the metal balls, metal spheres. And then you take away the charged rod, and that wham, we've got two metal spheres that have separate charges on them. At no point did anybody touch the metal spheres. And the word for this is charge by induction. Oops. I lost my place. Induction. Okay. So now I'd like to explain that's good stuff, but I think I already said all that. Now I would like to explain lightning. So this is a thundercloud, right? You reckon, oops, I got ahead of myself. That's a thundercloud, and the rain comes out down here at the bottom. Now, how does the rain form? Well, the water evaporates and moves up, and it forms a cloud. And then in a big thundercloud, the smallest water droplets move up with the updraft air. And once they're way up high in the cloud, way up in the top part there, they combine to make small droplets. So they go from smallest to small. And the small ones start to fall down through the cloud. So in the middle of the cloud, the smallest drops are moving up and the small drops are moving down and getting bigger. And as the smallest and small drops are moving up and down and they bounce off each other, that contact is charging by friction. So the small drops going down strip electrons off of the smallest drops that are going up. So the end result is the negative charges move to the bottom of the cloud and the positive charges move to the top. And that is done by charging by friction, because the smallest drops and the small drops are bouncing off each other. And the small drops make medium drops, and then the medium drops make large drops, and by the time it's a large drop, it's falling down out of the cloud as rain. The updraft can only hold so much water up in there. Once it's too big that the updraft doesn't hold it in the cloud anymore, it falls out of the cloud as rain. You like that explanation? I hope so. So here's there's 4 types of lightning. The thundercloud has positive charge up top, negative charge on the bottom, and there's 4 types of lightning. There's cloud to air. That's when the positive charge goes up into the atmosphere. And then there's intercloud. That's when it goes from the negative in this thundercloud to the positive in that thundercloud. Those are 2 separate clouds. It's going in between the clouds, intercloud. Then intracloud means it's happening within the same cloud. So the negative charges on the bottom of the cloud connect with the positive charges on the top. Then finally, there's the lightning that we all see and love, cloud to ground. That's where the negative charge at the bottom of the cloud reaches down into the ground. So let's talk a little about that. Oh, there's the picture blown up, so you can see the cloud to ground, the intra-cloud, intercloud, and then cloud to air. Now, I've taken this part of the picture and blown it up, right? So we see the negative charge on the cloud and the positive charge on the ground. But wait, why does the ground have just positive charge? With a large negative charge on the bottom of the cloud, this causes charge by induction on the ground. So the negative charge on the cloud is pushing all the electrons on the ground away. So they either go deep into ground or they go far away from the cloud along the surface. And now the positive charges are remaining on the ground. So we have positive charge by induction, on the ground. We have negative charge by friction at the bottom of the cloud. And if those negative charges reach down and touch and reach the positive charges on the ground, then they combine and make a bunch of neutrals. So that makes lightning strikes from the cloud to ground likely to happen because there's a positive charge on the ground from charging by induction. Also, air is a very good insulator. So in order for the static shock to go from the cloud down to the ground, it takes a large force of electricity to jump from the cloud to the ground. But I got to tell you, that's called lightning, right? It is the exact same electric shock that you get when you scruff your feet with socks along the carpet, and then you touch your little brother's back of the neck to make him jump. It's the same static shock. It's just one is amusing, and lightning can kill you. So static shocks can amuse you or kill you. Lesson learned. We done? Yeah, pretty much. Like I said, I don't make those. And we're done. Thank you so much. Good luck with the questions. They're pretty easy. Have a great day.